The printer is great, but it sounds like the soul of a drone is trapped within it. I measure 60 decibels from a foot away, and the HVAC system acts like a sound transmission line. Let's solve that problem. I need to dampen the sound coming from this 3D printer. It's loud enough that it can be disruptive to work, sleep, and even watching TV. I also need to be able to construct the solution within my apartment since I don't have access to a garage. It would be great if the solution was easy to handle so that it won't be a hassle to remove and replace before and after prints. It would be nice if there was some amount of thermal insulation as well. Many printable plastics can benefit from warmer environment temperatures. The solution needs to allow for connection to a wireless network, since that's the best way to get 3D print jobs to the printer. The printer and sound dampening solution also needs to be able to fit entirely on the counter in my laundry room, because that's the best place I have for it. Of course, I and the filament spool also need to be able to interact with the sound dampening solution and printer. First off, I could of course just buy an Enclosure commercial off the shelf. This would likely result in a solution that would be quick to deploy and inexpensive. A COTS enclosure would also require no design and manufacture time, as well as potentially having additional features such as air circulation and filtering included. However, the solutions that I have seen on Amazon are mostly made of either thin fabric or plastic sheets. These enclosures would have minimal, if any, sound dampening or thermal insulation. Most of the enclosures would have dimensions that are not optimized for my space and printer, so it might not even fit. Finally, most of the containments listed on Amazon that advertise thermal insulation do so with a thin metallic layer. This thin metallic layer could theoretically create a Faraday cage effect, inhibiting wireless connection to the printer. Designing an enclosure myself will allow me to include all the requirements that I put in place. I can include sound dampening walls that also help with insulation, customize the dimensions to my space, and ensure I don't create a Faraday cage around the printer. Of course, I would also gain some design experience, which I always find to be valuable. Although, this enclosure would likely end up being far more expensive to create than mass-produced COTS solutions, and it will be time-consuming to design and construct. As you can probably guess, I have chosen to build my own enclosure. The enclosures that I have found on Amazon just don't make the cut. Plus, creating custom products is what I like to do and is a big focus for this channel. That being said, let's get to designing. Unfortunately, I designed this before I decided to start a YouTube channel, but let's show you the steps I took. I start off every new design with some simple hand sketches. This allows me to figure out defining dimensions and helps define the most efficient way to 3D model the design. This is when I take measurements where I can, and even use my own intuition to initially size thicknesses. As you can see, they are intended to be the opposite of technical drawings. Afterwards, I created models in SolidWorks to ensure everything works out before I begin to build. I even created volume models for the 3D printer and sound dampening panels to ensure everything is sized correctly. As you can see in this assembly, I did not complete this assembly since it consists of repeating patterns on each side. Once I figure out the pattern would work on one side, I know it would work on the others, so I won't bother spending the time to complete the model in this specific scenario. Since this is my first project video, I feel I should let you know that in almost any scenario, there will likely be some sort of structural analysis done on any project to ensure that it will not fail. Different analyses may be done for different scenarios with varying safety factors, especially when a life is potentially on the line. However, in this case, I can use an engineer's judgment to know that the structure will be able to support its own weight, and it can't really fail in a way that will injure me or anybody else. In fact, if I manage to build this enclosure in such a way that it spontaneously explodes, I believe there may be an award associated with such an achievement. Anyways, back to the video. In case you are interested in recreating this project or working for my model, I provided the model on Printables for anyone to download and use. The link will be in the video description. Now I can export my models to the STL format and bring them into my slicer for 3D printing. I primarily print any of my parts out of PETG, as its properties better suit structural use relative to PLA. There is potential for other filaments to be used, but it's hard to argue with the price of PETG relative to other alternatives in this case. These parts finished in a flash thanks to my FlashForge printer, so let's get to the build. I first built the left and right sides of the enclosure by injecting hot glue into the corner pieces and pushing in the wooden dowels. I had included 45-degree markings on the corner pieces to help easily distinguish between the two angled pieces, but they didn't exactly turn out that great. I still know what I meant though. I then started attaching the two sides together with the perpendicular pieces, then moving to the angled dowels. In order to make it easier to put the front, top, and back together, I made the center parts in two pieces with a fastener helping hold them together. I then attached sound dampening panels to the frame with zip ties. This may not be the most elegant solution, but it was simple and worked perfectly. I did have to cut some of the panels down to a smaller size with a blade before attaching them to the frame. Note, do not buy these panels. In theory, they should work fairly well, but most of the panels did not inflate properly after being vacuum sealed. Although, it could be that they got too hot at some point while they were vacuum sealed, thus making this experience not the same as everyone else's experience. Once I got the side panels on, I recycled a brace from an inexpensive desk that I had in the past to use as a carrying handle. I just used a couple zip ties and existing holes in the brace to keep it simple. Finally, I taped the panels together using Gorilla Tape to help seal them together and create one continuous piece. Now that I have built this monster, let's test it out. After I placed the enclosure over the printer while it was printing, there is a drop of 10 decibels. A 10 decibel decrease is perceived to humans to be half as loud. This is a great result considering the minimal testing I conducted with the sound panels. I even used the super scientific meat thermometer to measure the temperature delta between the inside of the containment and the environment in my laundry room. After just 15 minutes of printing, the inside of the enclosure reached 102 degrees Fahrenheit, while the environment temperature stayed at 73 degrees. This has sparked a different concern that I had not entirely anticipated. How hot would it get if I printed something like an 8-hour print? How hot would it get then? The sound panels do claim to be flame retardant, but I'm not convinced that the temperature inside the enclosure would stop rising at 80 degrees Celsius or 176 degrees Freedom. Those temperatures would very likely start to create problems elsewhere. Although the enclosure is not completely thermally sealed, I will pay attention to those temperatures in the future prints, and may be adding a small vent of some sort in the future. It may not be pretty, but I couldn't be happier with my makeshift 3D printer enclosure. Sure, I could have spent more time and money building something from higher quality and optimized paneling, but the accessibility of this build outweighs that benefit to me. Speaking of accessibility, let's look at how much this enclosure cost to make. I decided to add up two total costs, one for the cost of buying an entire pack of the item, and one for only the pieces used in the pack. I did this because in reality a person would likely have to buy an entire pack of the product if they were to recreate this project, but really the leftover pieces could be used in different projects. especially when it came to the hot glue sticks and zip ties. I bought $8.79 worth of glue sticks, but only used one stick, which is only about 30 cents. I bought a variety pack of 1,000 zip ties, of which I only used 24 for this enclosure. That totals to 33 cents. By far the biggest cost to me was the acoustic panels, spending about $70 in total. If we were to include the dud panels that I ended up throwing away, that would be more like $100. The wooden dowels were the second most expensive, but that only totaled $31.24. Note that you may want to purchase a couple extra if you don't pick out the dowels yourself. I got at least one dowel that was almost as straight as a macaroni noodle. In the end, the total cost to purchase everything for this enclosure was $164.58. But if you were to part it out, the total comes out to $101.92. This is a lot more than any of the listings on Amazon, but we actually ended up with a significant drop in sound coming from the 3D printer. I could be wrong, but the same enclosure mass-produced to 10,000 plus units made would probably still cost around $250 to $300 to the consumer, in my opinion. Money well spent. Let's check that we achieved what we wanted with this project. The enclosure was definitely able to reduce the sound coming from the printer, even having the perceivable loudness. I was able to construct it in my apartment, even if it wasn't pretty, and I could have done something better if I had a shop space. The handle and low weight helped me make the enclosure easy to handle. Thermal insulation may have turned out to be too good, but that is to be determined. I can still connect to the printer wirelessly and print with no issues. Looks like this project was a success and may see an update in the future. Thank you for watching this video. Of course, you can subscribe for more videos on projects, product reviews, and tech from my unique perspective. Also, don't forget to like and comment. Since I have to spend much of my time adulting, I will likely not have a regular upload schedule for a while, but I will do my best and I hope you stick around.